Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. In this video lecture, we will discuss about the conservation of energy. First of all, we will discuss that what is energy. Energy is basically the ability of a body to do work. When work is done, energy is transferred from one system to the other. In fact, when a body does work, it uses its energy and transformed into other forms of energies. Let's move towards the law of conservation of energy. Energy cannot be created or destroyed. It may be transformed from one form to another. During transformation, the total amount of energy always remains same. During the energy transfer process, some energy is lost and does not remain available for some useful work. To understand that how energies are converted from one form to another and how the energy loss take place, we are going to take the example of a car. This car uses the chemical energy of the fuel and convert this energy into the kinetic energy. During the energy transfer process, some work is done against friction, which appear between the tire and the road, and also between the parts of machines which are used in this vehicle. Heat energy and sound energies are also created. But if we discuss about the useful energy here is only the kinetic energy, and all the other energies which are created are the waste energies, and these energies cannot be considered in calculations. In order to understand the process of energy conversion and conservation, we are going to take the example of a freely falling body. Here we have a body of mass m which is at rest at point A. It is at a height h above the ground, and when this ball is allowed to fall to point C, we will discuss the interconversion of energies and calculate the total energy at each point A, B and C. At point A, the body is at rest. Its velocity is 0. So according to the formula of kinetic energy, that is half mv square, the kinetic energy is also 0. So what other energy the body possesses at this point? As we are observing that body is at some height h, that's why it has potential energy which is equal to mgh. So we can conclude that at this point A, the whole energy of the body is only the potential energy. To calculate the total energy at the point A, we will take the sum of kinetic energy and potential energy. Here the potential energy value is mgh and the kinetic energy is 0. So total energy come out to be mgh. When the body is allowed to drop from the point A to B, it covers a distance x. At this point, the height of the body is h minus x and the potential energy is mgh minus x. At this point, the height of the body decreases, so potential energy also decreases. Then what about the kinetic energy? We are observing here that velocity of the body increases when it falls down from point A to B. So kinetic energy also increases. According to law of conservation of energy, the loss of the potential energy appear as a gain in kinetic energy. So for calculating the value of potential energy, we will calculate the loss in potential energy, then we will get the value of kinetic energy. If the total loss of potential energy appear as a gain in kinetic energy, then what about the waste energies and the air resistance? For our convenience at this point, we are going to ignore all the waste energies and say that air resistance is very small and can be negligible. To calculate the loss of potential energy at point B, we will find the difference of potential energy at A and at B. By putting the values here, potential energy at A is mgh and the energy at B is mgh minus x. By solving it, finally we will get mgx. This is the loss of potential energy which appear as a gain in kinetic energy. So kinetic energy of the body at point B is mgx. For the total energy at point B, we will take the sum of potential energy and kinetic energy. By putting the values here, EP mgh minus x and EK mgx, we will get mgh. So total energy is mgh. When the body moves from point B to C, its height becomes zero. That results in zero potential energy. Just before hitting the ground, the velocity of the body is maximum. That's why its kinetic energy is also maximum. So we can say that the whole energy of the body at point C is only the kinetic energy. And when the body hits the ground, its energy is dissipated as heat and sound and goes to the environment. For the calculation of total energy at point C, the potential energy is zero. Then what about the kinetic energy? We have already observed that at point A, the whole energy was potential energy and its value was mgh. When the body reaches point C, before hitting the ground, its energy is totally kinetic energy. So we can say that whole potential energy from point A is converted into the kinetic energy at point C. Loss of potential energy appear as gain in kinetic energy. So value of kinetic energy at C will be the same as the potential energy at A, which is mgh. Now by taking sum for the total energy, we will get total energy mgh. We have observed from the whole discussion that energy changes from one form to another, but the total energy of the body remains constant at each point A, B and C. So we can say that law of conservation of energy holds good in case of the freely falling bodies.